Good morning. Today we are going to work on an exercise to create a search engine index and to improve the index for better ranking and scoring. Just some background here. So we know that in information retrieval systems, the traditional way of scoring is based on keyword matching, right? So the more the matching of the keywords between the query and the document, the higher the document will be ranked, right? So that is what classic models such as TF-IDF, BM25 are based on, okay? Keyword-based matching and scoring functions. Now, on the web and on social media, this technique is very unreliable because people can dump keywords, right, on their pages, on their social media presence, whether it's a video or a tweet or anything related. So keyword should not be the only evidence for the ranking function. And so today we are going to take into account other evidence, for example, links on the web, right? And perhaps even the number of likes, the number of subscriptions on certain platforms that you can use to incorporate into the ranking function of your information retrieval index and scoring functions. So today, the data set that we are going to use as an example for this exercise is a fake news data set. And let me show you, this is only a subset from what I obtained from Kaggle. So this is the original data set, Getting Real About Fake News. It has been there for a number of years, and I processed it to create this subset of only just 150 news reports or articles on the web. Okay, and some of these are fake, some of these are real. And so as you can see in this small data set, each report comes from an author, title, content, which is the actual report. And then there are also URL and related things. But I want to highlight a couple of things here, which we are going to use in the end. One is the number of likes. So most of these are like zero values, but they are also positive numbers. For this particular entry or report, it's more than 400 likes. And so this is also an additional piece of evidence that we can use, right, to re-rank, to score and rank our documents, right? Because the more likes that one article receives, potentially it should be more relevant and perhaps more trustworthy, right? So this is one. And then the other is the spam score, which has been pre-computed and assigned. And so again, most of these scores are zero, but there are also scores such as, almost 0.3, which means there is a degree or likelihood that this particular post or report is fake or is a spam. Okay, and so for this particular score, of course, the higher the spam score, right, the lower the document should be ranked. And so in the end, we are going to take all these into account in the final ranking. Okay, and so a lot of these, just a background, because it was collected many years ago, part of it was related to the 2016 presidential election in the US. So that was that news cycle. So before we get started, we need to first create some mapping for our index. Okay, so mapping is to construct the schema, basically to define the basic data type and how data will be indexed, analyzed and indexed. And so we are going to rely on our tool, our dev console. Okay, and here is where we want to create our first inverted index. Okay, so we are going to put our mapping in there. And so what I'm going to do is just for the naming convention and to put this mapping into the inverted index, okay, before we start to load data. Okay, so mapping is the configuration and definition of data types and analyzers and so forth for the index. So what I'm going to do is to create an index, just follow this convention of making sure I'm having this unique index, and I'm going to just call it fake, okay, for fake news. And so under this index, what I'm going to do is to create mappings. Okay, so for now, I'm going to just simply copy paste all these, the properties and everything within the mappings. So on my left hand side is actually the tutorial I'm going to follow for this particular exercise. So when you put the JSON object as part of the API, make sure there is no syntax error. So if there is a warning on the side of this console, you should address it before you run it. But if everything looks good, we are going to just run this. But let me explain quickly what these are, what some of these, So in here, author is going to be a field from the data set here, the author field, and it's text. So we're going to index and standard analyzer. Published title, they have their different types, okay? But what we are going to rely on is one is title, and then the other is content for the keyword matching. And then the spam score and likes are going to be the additional fields, additional signals that we'll take into account later for the ranking or re-ranking of the articles. Okay, so let's run this to make sure the mapping is in. So it comes back positive, so the mapping is in. Now we know this is name of our index with this mapping. You may want to copy it, because right now we are going to go to a tool, and it is for the spreadsheet import. Okay, if you look at this icon here, and if your Elastic is set up properly, you can click on it, and then over here you can drag your file to import the CSV. Okay, so let me drag my spreadsheet over to the panel, and then I'm going to click next. And then the index name, make sure that we use the name of the index where we have already created the mappings. Okay, so this is the underscore map index. Now a couple of things under the doc ID for this exercise. Let's make it really simple, okay? And because we just want to use a very simple ID, which is the sequential ID, okay? So underscore line refers to the line number of the record. So the first record or the first line in the CSV or spreadsheet will be document number 1, and then second line is document number 2. Okay, so this is an example. And here you don't need to check on anything. We already have configured our mapping, so there's nothing you need to do. And if you want to remove certain columns from it, that's fine. But we're going to import all columns into this index, even though we will be focused only on the columns that we already have defined. So once you have these correct, let's go ahead to import. Okay, so we have that imported. Okay, so now just for a sanity check, let's go back to the console. And what I would like to do here is just to make sure we did have, you know, everything imported correctly into the index. So get, and then let me double check that my recording is on actually. Okay, so so I would like to use get and then slash the name of the index slash underscore count, just to get a count of the number of articles in the index. Okay, and if it come back with 150, which is correct, right? I have loaded 150 records or documents into the index. Now we can start to do some basic searching, right? Just to showcase that with the traditional technique of scoring, we can do some searching and find matched documents. So for example, again, we can really use this get and then the followed by the name of the index underscore search, right? And so this is going to be the search query. Now, let me copy paste from this document to make this faster. Okay, so this is going to be a multi-match query. Multi-match meaning you can search on multiple fields. Okay, and so we are searching for presidential election on title and content. And then this from 0 and size 3 is basically from is the offset. So remember, when you are conducting a real search on, for example, on Google, you are going to return, essentially, can be thousands, if not millions of documents that can match your query, right? But you don't want to return all the documents at a time. You probably want to return, like, okay, let's say 10 documents at a time. So in that case, you can say, I want the first 10. So offset from is 0, and then size 10 is going to return the first 10 documents. Now, I want to make it even smaller for this exercise. Let's return 3, okay, top 3 documents. And then we can run it, right? So this is going to return the top 3 documents for presidential election, right? And so here you can see that the number one document is this document ID 22, right, about Trump Tower surrounded by trucks. And then it has certain scores. And of course, you see in this document, there's no mentioning of the presidential election, even though the text, okay, the report, the content has that information. In the second document, you know, there's WikiLeaks and there is an election, right, in the title. And so if you look further in the third document, right, title, there's no election at all, right? So the election is in the content. So the reason why I show you these details is that sometimes maybe, yes, I'm searching for both title and content, but maybe you think it's important to match the title than the content, right? Sometimes like I want to search for presidential election, and if either presidential election appears in the title, that should give that document more importance. And so in that case, you want to boost that title field. And so I just wanted to show you a quick technique to boost that field. So for example, if you use this caret 10, for example, so if I want to boost the contribution of the title field to the scoring function 10 times more than content field, I can use caret 10. You can, of course, do 5 or 100. Like, it's really up to you. But let me do 10, so which is going to boost the content, the title field. And you are going to see we are going to retrieve some similar content here, but the document at the top will be different. Now you remember this document at the top is document 22 and the score is about 6. Okay, now the second document here is document 34 and the score is about 5.5, 5.6. Okay, let's rerun this with the boosted title field. And now what you realize is that this document with the election in the title is boosted and the score becomes 28. Okay, so the whole reason this now becomes the #1 ranked document is because that the election, right, this election from the query keyword appears in the title and the title is boosted, and so this one will be boosted to the top because of that reason. I hope this makes sense. Okay, now I promise, because as I said at the beginning of this tutorial or exercise, that we wanted really to incorporate certain fields or evidence or signals, such as number of likes and spam score, right, into this ranking, because we know if a report receives more likes, it should be boosted, right? It should be, the ranking should be improved. And if a report receives some spam score, right, that ranking should be reduced. And so with this in mind, we want to use the two fields, right? The number of likes and then spam score. Now, if you go back to the original spreadsheet, you will see a lot of values are 0. Okay, spam score, there are lots of values, 0 values. Likes, lots of 0 values. There is a problem with Elastic because of the specific technique that we're going to use is something we refer to as the rank feature. And rank feature, for the ranking purpose, does not allow 0 values. And so before we can proceed to use these values, we need to convert these values to non-zero, okay, values, positive values basically. Okay, so what the simple technique that we want to do is just to add 1, okay, to all likes. So because likes will start from 0, now it will start with 1. And then we are also going to add a very small value like 0.0001, right, to the spam score. Just to add a very small value. It doesn't really change the relative values of the scores, but it will make sure that the values are no longer 0. Okay, hope this makes sense. And so what I'm going to do is going to post an update, and this is also just a demonstration of a technique to update by query, okay, with the script. And so you can follow me here. So I'm going to post to the same index and the underscore update by query. And then following that, we are going to actually post the script. Okay, so I don't want to retype the entire script just to save time here, but I'm going to quickly explain what this is. Okay, so in this script here, what it's going to do is it's going to update by query, and because the query is match all, this is going to find all the documents. So this is going to apply to all 150 documents that we have loaded into the index, and then apply this script to update the likes field. Okay, so this CTX stands for the context, and underscore source, this is really the raw data. Okay, and then in the raw data we want to update what? Likes, right? Because there is the likes field. Remember this field, likes, this is now part of the index, and so we want to update it. How do we update? We want to add 1 to it. So we can use again CTX dot underscore source dot like, the original value of likes, right? Currently it may be 0, it may be 400, right? Whatever that is, we want to make sure that it's going to evaluate to an integer. So we use integer parse in to make sure it's an integer value. And then after we make sure that happens, we then add 1 to it and then assign it back to the likes, right? So basically we add 1, okay, to the number of likes. And so if we do that, okay, let's run it. Okay, and so what it does here, it says took and updated 150. And so if you see that, that means all 150 documents have been updated. We can check this later, but supposedly one value has been added to the existing likes. Now we're going to do something similar to the spam scores. Okay, so I'm going to just simply revise this query. Okay, so this script, spam score, and then of course this is no integer because script score is no longer integer value but a float. Okay, so we're going to use float and then parse float and then ctx underscore source and then again spam score. Okay, so change these two. Now I want to also show you something slightly different here because I also want to show you that you can potentially, instead of adding a 1 here, you can also have this different syntax of writing this. So I can reference parameters dot amount, and then in the actual parameter and amount I can put this, make a small value like this in there. Okay, so I'm going to add the small value. Okay, so this parameter dot amount is a reference to this amount under parameters. Okay, so this is will add this small value to the existing spam score. Okay, and then so make sure it's correct, and then we can run it, and hopefully if it comes back positive, again updated 150. So the spam scores are also updated. Okay, so we have updated the scores. Now here is one more problem. Okay, now in the existing index, if you remember the mapping, okay, so if I go back to the top, this spam score is float, number of likes is integer. Okay, however, because we want to use both of these fields for something we refer to as a rank feature. Rank feature is a very specific feature in Elastic. And so in order to use these fields as a rank feature, their data type should be rank feature, not integer or float. So how can we do that? Because we know in Elastic, once you put the data type in, once you put the mappings for those fields, you cannot change it. Okay, so what we are going to do now is just to create a second index with the new mapping and then copy the data over. Okay, so let's create the second index. And so what I'm going to do, and just also to show you some custom similarity as part of this, okay, I'm going to basically, again, you can copy the name. We're going to put, and then this index, let's call it fig2, just to differentiate from the first index. And then under this, I'm going to copy this particular settings. Okay, so in this settings, I'm simply making a couple of custom similarity functions. One is a custom similarity function based on BM25, which is the default similarity or scoring function in Elastic. Now, I'm making it custom function just by changing or adjusting the K1 and B parameters in it. Okay, and then just as an example, I'm also creating a custom version of DFR, divergence from randomness, and providing my parameters. Okay, so these are just custom versions of scoring that you can do. Okay, and I'm going to run this first. Make sure the setting is in place, and then I'm going to actually do the mappings. Now here I'm doing the mappings one by one. Okay, if you want, we can simply just copy paste but you also need to change certainly the name of the index so that it's applied to this index correctly. Okay, so I'm going to change, make sure that the content field is using the custom BM25. Okay, just some things for your consideration. And then, okay, then I'm going to also change other fields. And now you may wonder, why do I want to do one by one? We can in fact do this all together. So what you can do is that we can also copy the author field, okay, up to title, put a comma, and then paste this in, put another comma if you have additional, actually, for the number of likes, right? So this is, and I'm going to, let me finish the code, and then I'm going to explain everything just to make sure we understand where we are, right? So, okay, so I pasted the mappings for all the fields. So again, title is the text, and we are going to use the new custom version of BIM25. And then for the author, if you want Boolean similarity or scoring function, you can use Boolean. Our focus, however, for this exercise is on the likes and spam score. And because we want to use these signals or evidence for the new ranking function as a rank feature, we need to define the type as rank feature. Okay, this is very important. Define them as rank feature. And now, between likes and spam score, they are different, because think about this: the more an article, the more likes an article has received, the higher it should be ranked, right? On the contrary, the higher the spam score, the lower the rank should be, right? So in that case, for the number of likes, you should make this up to the, for the rank feature, you should make this positive scores impact to be true, which is default. You don't have to specify that in this case, but I just want to make it explicit. For the spam score, and this is, you have to specify, because the higher the spam score, the lower the ranking. So you have to, you must make this false. Okay, positive score impact is false, which means it's going to have a negative score impact, okay, for the ranking. So once everything looks good, run it, and it comes back positive. So we are good, right? So this Fig2 index is an empty index with all the mappings and settings ready. Now we can copy data over. One way, of course, you can go back to the import and then import data into this new index, which is going to work. But because we already have our data in the _fig, the first index that we have created, we can simply just copy the data over. Okay, and so in Elastic, the simple mechanism is just to post. Okay, so with post, you can, and then reindex. Reindex should have been named as copy. So this is the copy command in Elastic. And so let me copy and paste it. So for the source, we want to copy from the kind of the number one, right? From the fig, the first index that we have created. So it's _fig. For the second index, for the destination, is Fig2, right? We want to copy the 150 documents from _fig, right? From the source, okay, to the destination, which is _fig2, okay? So make sure they are correct. You don't want to change the direction, and then hit, play or execute. And so again, it says total 150, created 150. That's the most important thing. So it has, as part of this reindex or copying process, it has created 150 new documents in the index. Okay, so that part is done. Now, of course, if there's any problem in this process and you need to delete the documents, you can delete by query and match all. But of course, everything is good, so we don't need to delete anything, right? The delete, what I meant is that if something went wrong and you don't like the data that have been copied, you can remove them, redo it, right? Redo the process. So now with the data ready, we can go to our final portion of the exercise, which is to run some query on this new index. So that's let me copy this over, and basically it's something similar to what we have done. And of course, we want to run this on our second index. So I'm going to run this search on underscore fig2. And this is again a multi-match query on the votes. Okay, let's say we are searching for votes and on the title fields only. Okay, because right now I just don't want to make it too complex. And so if we run this, okay, I think I misspelled. Okay, so let's run this again, and then it's going to come back with 3 top documents, right? And so let's take a look. So the first document, the score is it's ID 134. The score is 3.6. Okay, and it does match, right? So there's vote and there's a vote, right, in the title. But one thing you want to see here is that the number of likes is very low, only 1. Actually, it's 0 because we have added 1 to any value, so no one really is liking this. But if you look down, I mean, to the second document, right, the number of likes is higher, right? So, and this also has votes in it, so it's also a match. And so if this receives more likes and it's also a match, it should have been ranked higher, right, compared to the first one. So this is document, let's see, this is document 111. Okay, easy to remember. So in this case, we should really use the number of likes and spam scores as our rank features to boost the similarity. Okay, so let me again run this query, okay, with the new one, and this is going to be the last one that I'm going to show you today. So I copied this in, okay, so underscore search, and then there's a query to search on the votes field. Okay, you can use multi-match, that's possible, but here I just want to simplify it with just a simple match query. And then you see here, as part of a query, I make it part of a Boolean query. Okay, and the reason is if you want to use rank feature, such as using the likes field, okay, the ring feature should be part of a Boolean expression, because ring feature is very efficient, it's indexed, but the downside is that it's less flexible. Okay, it doesn't allow you to really customize your ranking function. But the customization can happen to some degree as part of the Boolean expression. Okay, so here I use a Boolean query, and then rank feature is part of should. Okay, and for those of you who are familiar with Elastic, in Elastic query, Boolean expression should is the equivalent to or condition. Okay, and or, mathematically speaking, is the equivalent of addition. Okay, so when I have an should here, okay, with the rank feature of likes, I'm basically adding the number of likes, okay, to the existing score. Okay, whatever score, and this is BM25, a version of BM25. So on top of the BM25 matching score, I'm going to add number of likes, okay, to that score. And because I want to avoid a situation where the likes can totally dominate the equation, because think about likes can be like here the score is like just 3 or 4 or 5, right? It's a small score, but the likes can be 400, even 1,000, right? Huge number. So I don't, if you add the like to it and likes are hundreds or thousands, that would totally dominate the equation. And so in that case, I want to kind of dampen the impact. And so you can introduce this saturation function, okay, with the pivot value. I don't want to further elaborate, but very simple, briefly, saturation is simply to reduce any numbers into the range of 0 and 1. Okay, so you are normalizing the number of likes into 0 and 1. So it becomes a smaller value, a much more manageable range that you can use, and then add this 0 to 1 value to the existing score. Okay, so that is the end, the kind of the final scoring. So let's run this. And again, this document is 111. Hopefully it will go to the top when we rerun this. And so indeed, 111 becomes the top. And you see, this, it was previously 3 point something, now it's 4 point something. So it's adding almost close to 1 value, okay, to the existing BM25 score. And so in this case, we see this document is boosted because it receives a larger number of likes. And so you can apply the same, okay, using spam scores, something similar. But I will leave this part for your own exercise. Okay, so with that, we can conclude this part of the tutorial or exercise. And keep me posted if you have questions. See you in the next one.